Hello, how are you everyone? This is your instructor Junli again. Today we are going to talk about conditional probability. This is our second lecture for February, week of February 7th. The due date for the second homework could be 14th of February. So let me share my screen with you. Okay, last time we were talking about the probabilities, right? Today we are going to talk about conditional probability. The concepts are very similar as before, probability, but it's gonna be like conditioning on something, you know. So the homework in slide 2 is slightly more challenging than other homework, but this will be potentially, very, very important. I mean, especially when like in advanced statistic, understanding conditional probability is very important. So let me give you some motivations and what kinds of things we're gonna talk about. The text book chapter would be this. You can feel free to read those textbooks. Today we are going to learn this. So that is basically extension from multivariable probability. Last time we learned about joint probability, marginal probability. Today is also extension of it. So first part, we're gonna talk about conditional probability and statistical independence. So how to compute conditional probability and how to check whether two events are statistically independent or not. So Bayes' law, this is basically similar to the conditional probability, and we're gonna test that as well. Part 1. So we will consider 3 examples. Is there discrimination in hiring process, and does high school tuition lead to higher salary? Saturn and Trump market share of the car makers. So I don't know which jobs you're gonna take later, but these are potential examples that we're gonna discuss. I mean, you can extend in to many other examples, but we're gonna just focus on 3 examples that why conditional probabilities are important. Okay, so let's look at some discrimination thing. I mean, these are something similar, right? I mean, this is male and female, this is hired and not hired, but instead of we write this as not hired, we said higher complement. So again, complement was just 1 minus probability of higher, so or 1 minus higher. So this is a frequency table, but we can change this to probability table. Do you guys remember how we did last time? So first you need to count how many people in the sample. So how many people do we have? I think it's, I don't know, it's 288 plus 36 plus 672 plus 204. So whatever number that is, if we want to find the probability, so this one is a probability of H intersection M, which is joint probability. So if I ask you what is the probability that a guy is hired, is just probability of so 288 over whatever summation we have. I think it's 1200. So it's a 288 over 1200 would be your probability that a guy was hired, and this is a probability of female hired, which is 36 over 1200. And this is a probability of a man is not hired is 672 over 1200, etc. So in exam, if I give you a frequency table, you should be able to convert this to probability distribution, right? So for example, what is the probability of higher the female applicant? So I'm looking for this, right? So as I discussed, you can find joint probability. Again, pause this and try to convert this to probability tables first. So I'm looking for probability of female higher, that is 36 over 1200, which is joint probability. So this is joint probability. So one of the most important distinction and hard thing in the conditional probability is sometimes I ask you what is the a probability of higher female applicant. So that is basically a probability of female intersection hired, right? So that is a probability or joint probability. But conditional probability is something like, okay, conditioning on you are hired, what is a probability you are female? Or conditioning on you are female, what is a probability of hired or not hired, or etc. So that is a conditioning on. So the terminology I tend to use is just suppose or conditioning on. So I mean some or if. So in exam, I'm gonna use if statement for conditional probability. So you can know this is exactly conditional probability you are looking for, because the way to serve or the intuitions are quite different. So I want you to focus on that part. So do I see any gender discrimination? For example, this is probability of female intersection higher than 3%. In other words, if we convert this to the probability distribution table, so that would be 3%, which is 36 over 1200. This is 24%. So we see this is a 24% and this is 3%. And based on that, do you see discrimination? Before you answer that, please think a little bit. So the probability of a higher the male is much higher than the higher female. But based on this simple statistic, can you say the discrimination? I would say no, because I mean, one can say, I mean, of the summation of male is what? So 288 plus 672 is it's like 80% of the population. I mean, the applicants are male. So because there are more males than females who apply the job, that's why, you know, they have a higher probability of this 24% and 3%. So one can argue that, okay, I mean, since they have a more number, that's why this number is higher. Based on that, we cannot say this is discrimination. So to answer more discrimination, we can go further. Like, well, a fair comparison would be, for example, probability of hiring an applicant if. So again, this if statement that I'm gonna use a lot in this course is like a conditioning on. So if I say condition, probability of hiring an applicant, conditioning on the applicant is female or male. So that is basically what I'm looking for. So in exam and also in homework, I said if something then happened, that is basically a conditional probability. So this is a conditioning statement. So that is very important. So conditional probability of hiring an applicant given. So given is another statement I like to use, given that the applicant is a female. So I made. So the answer is, so, okay, so how many male do we have? So 288 plus 672 male applicants. So out of this number of male applicants, what is the probability that they are hired? So in other words, 288 out of the summation of these two are higher. So that is basically conditional probability. So we do not even think about female data because we are only looking at conditioning on they are male, what fraction of people are hired. So this is how you calculate. So formally, this is how you are looking for this one. When you have a frequency table, you can basically looking at that. But later, I'm gonna show you some the formulas you can use. But basically, idea is very, very similar. So basically, 30% of male applicants are higher. So this is would be more fair comparison. So how about that? So please try to spend this one. So very good example. So what is the conditional probability of hiring an applicant given, so conditioning on applicant is a female. So how many female do we have? So 240. That should go to what? Numerator or denominator? They should go denominator, right? So we are only looking at female, so we don't even care about male for now. So 36 out of 240 are hired. So answer is 36 over 240. So this is a formula. Very important formula. So probability of A given B equal probability of A intersection B over probability of B. Very, very, very important. Very, very, very important. So for example, I'm saying, let me show you in board what is the meaning. So for example, I'm looking for probability of, somebody is hired given female. So based on the formula, I can say probability of H intersection F over probability of F. This is very important. So the highlight of a homework 2 is based on this. You're gonna use, if you don't know, you can even solve the homework 2. So this is your formula. You can take it like that. So So that is okay. Probability of a higher. So in other words, there are two ways of rating this. First is okay, probability of age given or slash conditioning on female. Second thing is if applicant is female, then what is the probability of age? So that is another way of saying. But in homework 2, I'm gonna focus on this part. But either way is fine. But okay, probability of H given AF is something like that. So how is it working? So so basically that is extension of the formula. So you can actually use the frequency table or using this one. For example, there are two ways you can do it. This is equivalent to saying that frequency of basically H and female over frequency over female. So total number of female, I said 240, and how many of them are hired who are female? So that was 36. So you can calculate this as a 15%, right? So this is using frequency, but let's say in exam, you didn't have this frequency table, right? So then how you can do is using this one. So I like this method. And also this method. So I don't know which one you're gonna see in the examples. Something you definitely need to keep that in mind. For example, this is higher. No, actually it's not higher. This is male and female. This is higher than not higher. So something like that. I said it's a 288 over 1200, but you can say this as what, 25% and 3%. Was it 3%? I think it's 20 something like that. Let me do the 24% is right at 24%. So that would be 24. So you can get these probabilities, right? That was let's actually coming back to this example. How do we get that? Is um, basically the same. Male, female, HC. That also 288, 36, 204, 672. So you can get the convert this probability like this. So let me use my calculator. So this is 204. 204 divided by total population 12. So that is 204 divided by 1200, because that is how you get the joint probability, right? So that is a 17%. So that is a 672 divided by 1200. That is 56%. So as you can see, this summation of that is based on this distribution, you can get the probability. Okay, what is the probability of man? So probability of man. So previous course we said the summation of a joint probability is a probability, marginal probability, right? That is 80%. That being said, without looking at that, this got to be 20% because the summation of this is 100%. And you can confirm it's 3% for 17 is 20%. And this is a 27% is probability of higher, and this is basically 73% is probability of not higher. So very tough market. So very hard to get a job. Okay. So if we use this formula, so what is the probability of H intersection F? That is here 3%, right? So that is equal to 3% over what is the probability of female? That is 20%. So that is equal to 15%. 3 over 20 is a 0.15. That is 15%, right? So as I show you in this example, there are two ways. Either way would be fine, but sometimes in the exam, I only give you this percentage, then you cannot even use a frequency, right? Because I didn't even give you the frequency. Or I mean, you can technically make imaginary numbers, like basically imagine you have 1,000 people, that means it's 30 people, 240 people. So you can make it, but I think you should also know using this method. This is more widely used, but this is as important as this. So any question? If you have any question, just again, let me know. I'm happy to go over any question you might have. Shoot an email, or if needed, we can schedule a meeting. Okay. So the probability that the female was hired was 15%, but previously a guy was 30%. So do we see discrimination? Yeah, I think based on the conditional probability, we see some discrimination. So there can be a conclusion, right? So this was the formula, right? Very important. So don't get confused. These are totally different because the big over here goes to denominator, right? The A in here goes to here. So that would be totally different unless probability of A and probability B are the same. So they are totally different. So do you see discrimination? Yeah. This is a multiplication rule. I mean, this is nothing hard at all, right? For example, if you multiply probability A both sides, right? You get this. So not a big deal. So basically this, if you multiply probability of A here, probability of A here, probability A can be canceled out, and it's the on the left-hand side would become right-hand side here. So that is probability of A times probability of B, given A. So not a big deal. So you can use this one. Again, as I mentioned last time, I'm in this course, I'm gonna focus on Tableau and R program, but I also wanna focus on Excel. So I'm not gonna show you, demonstrate this, but definitely these are the function you can use that. So just keep that in mind. So the probability of A given B is a conditional probability of A when B occurs. So B occurs first, and then we are looking for A, but this is a complement. So when A was not occurring, so probability of A is not occurring when B occurs. So those are some rules. So you can take a look at that. This is also very important. When B occurred, there are only two cases, A occurred or not. So basically, this summation would be equal 1 because probability of H hired given female is a conditional probability of conditioning on they are female, they are hired. Plus probability that given they are female, not hired. So either they're gonna be hired or not hired. So summation of this conditional probability should be equal 1. In other words, if you do some algebra, that is equal to this, right? Something you can keep that in mind. So this is similar to the complement rule, right? So previously we said the probability of H complement equal 1 minus probability of H, but in conditional probability, you're gonna get the same result. But note that these are not the same. You can prove this yourself, why this is not the same. Very good exercise. And let me know if you have a question, whether you can get this or not. Okay, this is another type of exercise. So, I mean, people tend to go MBA, because they expect, oh, they're gonna get higher salary. The tuitions of MBA are so expensive, So the fair question to ask is, I mean, does like an MBA graduate from high tuition school have a higher chance of large salary gain? So we are looking for tuition is 50K or higher. T complement is tuition is less than 50K. So the question is, okay, if you are attending a school that tuition is high, do you get higher salary? So the question is, okay, this one, please spend some time trying to answer this. So we want to show that this is a very important research question. We are setting up the problem and get the probability like that, but what kinds of information should I use? This is very, very tricky. So try to spend think each individually what that means. I mean, it's okay. You can spend like 10 minutes just thinking about that. That would be really nice exercise actually for you. So I recommend that. But I'm gonna reveal the answer in a bit, but please think carefully this. Okay. So okay. Want to show the high tuition has nothing to do with high salary gain. So let's thought about this. So what do you really need to show is what? So I'm gonna reveal the answer that would be here. So for example, I want to know the probability you are getting higher salary, here, given you are paying higher tuition or not tuition. So I'm saying probability that you're getting higher salary would be the same whether you are paying higher salary or not. So that is why this is answer. So again, you want to know high tuition has nothing to do with high salary. That means conditioning on you're paying higher salary or conditioning on you're paying low salary, your salary, I mean, no, sorry, conditioning on you're paying higher tuition and conditioning on you're paying lower tuition, you are still getting the same probability of getting higher tuition, I mean, higher salary. So that would be the intuition. So you can calculate this, using the formula. So probability of S given T is using the formula is probability of S intersection T over probability of T based. So again, that is why I said earlier. I mean, you can get the conditional probability using frequency distribution, but this case I didn't give you even frequency distribution, so you can get the conditional probability out of this probability. That's why this is more widely used. So, but you still got to know the concept of both each other. So, so based on that conditioning on, you are paying higher tuition. So probability T or marginal probability of paying high tuition is 45%. That is basically 45% was 11.25 plus 3.75. Summation of these two is a probability of T or marginal probability, or summation of each joint probability, right? So it's 25%. So I'm saying, okay, then calculate that. And then what is your conclusion? So I show in this example to find this conditional probability. So how do we get this one? So I'm gonna leave you the answer, but you got to try. Okay. Um, Actually, let me show you in the slide. So you can calculate this one using exactly the same thing. So same formula, just plug in the, but now that your numerator, denominator both change, it becomes 13.75. That is coming from over here, right? Probability of S intersection TC, and probability of paying lower tuition is summation of these two numbers, right? Probably, I mean, 13.75 plus 41.25, that is marginal probability or probability of TC. So this is how you get 25%. So based on this example, oh, we get the same. That means, I mean, paying higher tuition doesn't mean you're gonna get higher salary. So I mean, this is just example, doesn't reflect anything. So, but this is just practical example. You can always test it out. The statistical independence is a very important concept anyway, as well. So we said the two events A and B are statistically independent if probability of A equal probability of A given B equal probability of A given BC. So that being said, let's say if we are looking for a probability of paying, I mean, getting higher salary. So that, I mean, so let me not make that statement because that might be different. So, I mean, this equation is saying whether what kinds of event B happens, whether B happens or B complement happen or nothing happens, you still get the same probability no matter what B happens. That means A and B are nothing to do with each other. So that is how you prove event A and B are independent. So I'm gonna actually ask this in midterm. So make sure you guys study, okay? This is a very important concept. So for example, if I want to know, okay, what is a problem? I mean, how do we find the two events are independent? Then this is a way, one of the way you can show. So another way of that is here. So because A and B are nothing to do with each other, so whether you are conditioning on B or whether you're conditioning on A, it should give the same answer. So probability of A occurring is the same for different condition when B has occurred or not occurred. So when it's unknown whether B occur or not, so or throughout this probability, the probability are the same. That is independent. So given this one, so let me show you something interesting for you. Okay, um, let me share my other camera. Okay, so okay, I said so initially the probability of A given B equal what? It's the probability of A intersection B, right? Over probability of B. This is basically the formula. So if they are independent, right? If they are independent, I said this is equal to what? Probability of A, right? So probability of A equal probability A given B. So I can substitute that, right? That means probability of A equal probability of A B over probability of B, right? So if we multiply probability B both sides, then probability of A intersection B equal probability of A times probability of B. So this is a very, very popular way of showing these two events are independent. So if probability of A intersection B equal probability of A times probability of B, then we say these two events are independent. Very, very, very powerful tool. So you see over back there, right? Okay. If you missed, please go back like 10 seconds ago and write down. Very important tool. So economic example is vaccination independent of getting a disease. So does vaccine is effective, in other words, or GDP growth of US, EU, China independent? Today's stock return independent of tomorrow, etc. So interpretation is A has no effect on B. So between the two groups of this outcome is the same. Information A doesn't have to predict B. So these are some examples. How to check independence? You can use this method. You know, this is not what this doesn't mean they are independent. So if and only if probability of A equal probability of A given B equal probability of A given B complement, if that is the case, then you say independent. So there are a couple of ways to check independence, right? So another way of this is something I just show you, right? So very, very famous from multiplication rule. So very important. So these are some examples. Again, I tend to show probability distribution instead of frequency distribution because sometimes these numbers would be like couple millions. So instead of we show that whole number, these are very typical, like showing probability distribution. So that's why I ask you to memorize the formula. So let's say these are some, this is a probability of H is Honda's market share, probability of H given S is Honda's sedan market share. So conditioning on sedan, what is the Honda's market share? So conditioning on truck, what is the Honda's market share, etc. So, so can you say H and S are independent? Honda and sedan are independent. Can you say that? You can actually use these examples, right? I mean, so I just revealed the answer, but based on the things we just learned the previous pages, try to reveal whether you get the same answer, okay? Very important exercise. So check if probability of H is probability H given S equal probability H given T, or you can even use this formula. So this one, it doesn't matter. So try to check whether you see these two events are independent. So I'm gonna leave you the answer. So these are the answer. You see clearly these are not the same, so they are not independent. So, and or another way of doing is this one. Obviously they are not equal, so not independent. I'm skipping a little fast, but because I explained in detail earlier, but it doesn't mean you can skip that fast. Make sure you spend some time whether you get the exactly same numbers. If you don't get exactly same numbers, go back to the previous slides, or I mean a couple of pages before, and check whether you applied exactly same formula, or if you still don't get it, just email me. We can discuss it together. So we can ask Ford and trucks are independent. It's a yes or no. So I'm looking for Ford and truck. So you can actually compare. I mean, usually exactly the same method, either multiplication rule or the definition of the static independence. So I'm not gonna actually go. I mean, give you the answer. Please try to check. This is a very good exercise. Okay. So part two would be how to convert this one to this, or how to convert this to this, something like that. I mean, this is not hard mathematically, I mean, but let me show you. So we consider manufacturing quality control of defective rate and Down syndrome screening test accuracy interpretation. So let's say, suppose that a manufacturing firm receive a part from two different supplier. Supplier one, which we say A1, supplier two is A2. A1 supplies 60%, A2 supplies 40%. So we want to know, I mean, we have some information, 2% of A1 parts are defective and 7% of A2 are defective. So these are very potential, actually, the questions for exam. So what do you think though? I mean, based on this, if I give you this information, and how much information can you extract? Please try to think this how much information you can get it. So that is 2% of A1 are defective. What is that meaning? 7% of A2 are defective. So based on this information, you have the supplier A and A2, and you have parts are defective or not, right? So you can get the distribution tables like before. So um, for example, you can put something like let's say I'm gonna just write over here. Oh no, actually, let me change the videos. So for example, you can write this as okay. This is A1, A2. So so first, in conditional probability, try to fill this table first. So this is defective and this is not defective, right? So I told you that so given the information, we said given this information, I told you that okay, probability of A1 was 60%. So which implies probability of A2 equal 40%, but I gave this one. So in actually homework 2 would be very, very similar to this. I gave you some probability, but you still should be able to recover a table like that. And it said basically 2% of A1 parts are defective. That is one. So 2% are defective, but A1. So probability of defective conditioning on A1 is 2% basically. So 2% of A1 part are defective means the conditioning on A1, the defective rate is 2%. Similarly, I said conditional rate defective is given A2 equals 7%, right? So how do you write down this as a formula? So given that, we know this is a 60% because that is marginal probability, that is a 40%, right? So given this, what you can get is, okay, okay, how do we fill this one? I know this is what? this is using the formula, this is equal probability of A1 intersection D over probability of A1, right? Using the formula. Similarly, this is equal probability of A2 intersection D over probability of A2, right? But we know probability of A1, this is 60%. In other words, I'm saying 2% equal probability of A1 intersection D over probability of A, which is 60%. So that is a 60%. 60% is 0.6, that is 0.02. If you multiply, you're gonna get this probability. So if you multiply this, it's gonna be what? A point. So in other words, this implies probability of A1 intersection D equal 0.02 times 0.6. So easy. So you can find a similar probability. So I just get that A1 over D1 is a 0.02 times 0.6. Similarly, this one is a 0.4 times 0.07. And since we know these two probability, we can figure this one, right? Because summation of these two are equal to 0.4. So 0.4 minus this one would be this. So it's a 0.4 minus 0.4 times 0.07. This is a 0.6 minus 0.02 times 0.6. So you can figure the probability of this. This is a probability of D, right? This is probability of DC. So that is summation of this. So using calculator, you can get all the probabilities. So how easy it is. So I mean, it looks initially very hard, but all the informations are basically coming here. So this formula is basically the highlight of the chapter 2. Very, very, very important. So yeah, make sure you guys go over several times of this recording and you get 100% of it. Very important. It's gonna be on the homework and as well as your exam. So try to recover exactly what I did, okay? Step by step. So let me go back to here. So these were the information. So based on this information, you know, I was able to extract those information. So very, very important. So this is, I mean, I already gave you the answer, but try to think about it. So 2% of A1 are defective. That means what? I already revealed the answer, but these are the something you should keep in mind. So I said the probability of defective given A1 is 2%. So 7. So probability of defective given A2 is 7%. So answer is A. But try to think why B, C, D, E are not the answer. Okay. So given that, we are able to get that. So we would like to calculate that based on that information. First thing is first, you got to fill the this blank first. So in this example, I mean, so on slide I said say there are 1,000 parts. Reason for this is I try to use a frequency distribution method that I described earlier today, but in the actually on board, I describe this method, but either ways are fine. So the way I show you over here, I use this method probability distribution, but the example I show in the slide are frequency distribution. So this is something I described earlier. So imagine that you have 1,000 parts. That means since the probability of A is 60%, that means this part would be 600, this would be 400, etc. So we can draw a tree and then we can finally get something like that. Okay, 12 parts are defective, made by A1, 588 are not defective like that. So that is something, if you imagine there are 1,000 parts available, you can get, for example, so if we have, imagine you have 1,000 parts, that means this would be 600, this would be 400, and this is basically 12, right? And this would be 28, I think 28 is right, 28, etc. So you can get like 372, and this is 588, something like that. So using this frequency distribution, you can still get the answer, but I recommend you to use the probability distribution because that was given in the exercise. So it doesn't matter. So for example, those are I explained in detail. I think in slide um, um, over here. So the way I show on the board was using this method, and on the slide I used this frequency method. So frequency method, since I didn't give you any frequency, actual frequency, so I actually gave you some imaginary number. Let's say there are 1,000 parts and some. So either way would be fine, whichever convenient to you. But I prefer to use the first method, and I want you to actually get familiar with that method as well. But again, you got to know both methods. So that is easy. So once you fill the probability, then probability of DC given A1 is probability of DC intersection A1 over probability of A. So we know the denominator should be 600, and numerator is a probability of DC intersection A1. So that was, if you're coming back, is we are looking for here 588. Or if we are looking for to solve using the method, this method, then you are looking for this. So probability of D C given A1 would be equal probability of DC intersection A1. So in slide again, I show you in frequency method, but in here I show you this method. So probability of A1 is 0.6, and this would be what? 0.6 minus 0.02 times 0.6. So you would get exactly the same answer. So, okay, so so you can get this one as 588 over 600, but actually coming back, it said 98. So let's try to get, we get 98. So for example, 0.02 times 0.6 is 0.012. So that is equal 0.6 minus 0.012 over 0.6 equal 0.588 over 0.6, that would be 90% if we plug in the calculator. Either way, it would give you 100% same answer, but I think this is quicker, personally. So you can simply also get the complementary rule, like since you know probability of D given A is that, so definitely probability D C given A is 1 minus of this. This is another way. Either way would give you the same answer. So what is the probability of D? I mean, that is easy, right? So probability of D is a marginal probability, which is summation of this. So you can either use this black one, like a 0.012 plus 0.028, so which is a 0.04 or 4%, or you can say 12 plus 28 divided by 1,000. This is still 4%. So it would give you exactly the same answer. So try to check whether you get the same answers anyway. So this one, using frequency method, you would get exactly the same thing. Okay, so this is actually something you can explore like later, but I'm not really focusing on this a lot of this because this is just pure math. I mean, for example, we know probability of D given A1 is a probability of this is basically same because let me say in word like probability of D given A1 is probability of D intersection A1 over probability of A, which if you cancel out this whole term would become probability of D intersection A1, which is joint probability of this. So basically you're gonna get joint probability of this, which is probability of A1 intersection D. And second part, similarly, you're gonna get this joint probability of A2 intersection D. So definitely summation of this is probability of D. So this is hard way of saying these are the same. But if you know intuition, you don't even need to memorize this stuff. So honestly, if somebody just show me this and can you say these are correct? And I mean, since I never memorized the formula, I say I need to check it out, but I can check mathematically whether they are the same. So that means you don't have to memorize, but you got to understand. So this one, you can also do the similar thing, you know. If you pick a defective part or random, that means conditioning on D, right? Conditioning on defective. What is the probability of A1? So this exact statement, I mean, similar statement are used for homework too. I say if you pick a defective part at random, that means it's conditioning on part is defective, the probability of A1. So I said the probability of A1 given D, so that is here, you can get this is like this. So 30%. So not hard error. So this is another way of saying this is, do not bother this too much, because this one, again, you can prove it because this is, again, a probability of D given A1 times probability of A1. You can multiply that, you get probability of A intersection A1 intersection D, so which was the same as the denominator, I mean, numerator we used before. Similarly, we just covered that this is a probability of D. So this exactly saying probability of A1 given D is a probability of A1 intersection D over probability of D, which is the same. So this is like a Bayes rule, actually. Some fancier way, but the idea is very simple. You can actually, I mean, I show in example, but you can always prove it. So I'm not gonna too much discuss this because it's quite intuitive, but this is called the Bayes rule. Okay, so based on Bayes rule, you can calculate, but honestly, you know what? I mean, you don't even have to know, calculate everything to get this. As long as you can recover this either frequency table or probability distribution that we actually went over together, you can calculate anything. So that's why I don't want you to memorize the Bayes rule. You can understand it for sure, but you don't have to memorize to find, for example, probability of A1 given DC using this method. You can recover any way you want. So uh, so this is again A1. You can, I mean, you can try to solve it. So using Bayes rule, you can find the answer, but this again, you don't basically you are asked to find the probability of A1 given DC. That is, but you don't have to use this Bayes rule. Okay, so the last example would be Down syndrome example. It would be exactly same. So that's for the reason I'm not gonna cover in class, but I want you to actually try. But if you actually look at this example carefully, I will definitely, I mean, if you have any question, I will happy to go over with you. But this is the same. So please take a look at, and if you follow it, that is good. But say I said just using 10,000 babies to get the information. So again, this method is using distribution. I mean, the frequency method, but I want you to try with also the probability distribution method. So if you guys have any question, just let me know. I'm happy to discuss more, but for homework too, that is more relevant for the previous example, so that's why I focus more on that. Try to understand the wording, like if something, then something. So that is basic conditional probability. You should be able to do the homework. So, okay, thank you so much, guys, and have a good day.